Okay, so I'm going to continue from last time. And last time we were looking at prototypes, talking about different ways of creating new objects that have shared functions. Normally we use it in an object-oriented language like C Sharp or C++. You use classes. And when you create an object out of a class, you inherit that object gets all the functions from that class. But in JavaScript, it's different. When you create an object, you attach a prototype object. And all the functions of the prototype object get inherited into the new object. So there's no class. Now they've been changing the language. And I think the new versions of the language use the keyword class and constructor and some other mechanisms to make the language look more like C++, for instance. And I'm not going to go in that direction right now. I'm not going to look at that new stuff. I'm going to just look at the old core, prototype-based handling of shared functionality between objects. So that's what we talked about last time. And then what I wanted to do was start using that canvas element to do animations and start building kind of like a game approach to making mini games in web pages. So let's go ahead and do that. There's an element called canvas. Let's give it an ID. We'll call it. I'll call it the. What am I going to call it? Frames per second. It's going to just show frames per second. And then the script. In the script, let's go ahead and work on that. I'm going to put this in an anonymous function that I invoke immediately. So that's how I make sure I step out of the global namespace, just as a habit. And so let's get this FPS canvas here. There's a document object with the function get element by ID. And we can use that to get our FPS canvas, or frames per second. So we're just going to render a calculation that's estimating the frames per second that we're drawing to the canvas at. And once we have this canvas, we'll give it a width and a height here. So width is say 400, and height is say 200. I make it 300. And once we get the canvas, we can draw into it. So there's a context. It's usually abbreviated CTX. And we take that canvas object and we call get context. And that returns this context object, but we have to tell it what type of context. If we want to use the 2D API, then we're going to ask for the 2D context. Maybe it's lowercase d, it probably doesn't matter. It could also be, WebGL, that's another context. I'm sorry. There's another one. And there's some others too, I believe. It's really the two are the 2D and the 3D context. Well, there may be some others in there. I think they keep expanding the API all the time and adding more and more to the browser capabilities. So there we have a context, and then once we get this context, we operate on it by doing things like setting the fill color. I think it's was it fill style? I think fill style equals. I think we can set the color somehow. Let me look at that. We're going to go canvas, context, fill style. So get an example here. It'll just equal color. There it is, right there. And in fact, we could just do this example right here. Say the fill style is, say, red. And then we can then issue a drawing command, which is to fill a rectangle. Starting at XY coordinate 1010 and going to a width of 100 and a height of 100. So that's a square. It's 90 by 90. I'll make it a square that's 100 by 100. So this should render right now. Let's see. There we go. So it's in the canvas. Let's make sure that we got let's add some styling. I just want to check that the borders are working right. So if I put a border around everything, 1 pixel wide, make it green and solid lines. So it's 3 settings all at once. This, by the way, this is equivalent to something like the following. Border, is it border width? Border size? Border size? See, I'm not sure. I'd have to look it up. And then there's border color. And the other one is border like style or line type. You got to look it up. So yeah, I don't know. See this is shorthand. See the 3 settings? This is the border thickness. This is the border color. This is the border style. Is it solid? I mean, it could be dashed. And there's a button dotted, I think, and there's some other ones. None. Turn it off. But I don't know. This is the, like the abbreviated shorthand form. But you can write it out and specify each of those styling elements individually. But I'm not sure about these names here. Let's check it. Let's check it. So CSS border properties. Let's do that. Border property. Let me try this one. No, I can't believe it. They didn't show it to me. This is style sheets border. Oh yeah, here it is. Border width, border style, and border color. Okay. Yeah, I got it right, didn't I? That's border style, border color, and border width. There we go. So the canvas is, you know, it's 300 wide, 200 deep, 200 high, right? That's or 400 by 300, right? That's the 400 by 300 canvas here. And then this green one here, this is the body. So the body has a border of some default border that we didn't set. Let's take a look at it. If we look, see this body element here, I'm just selecting that. And I'm going to look at the styles here. Look at this. The border green, border width is 1 pixel. These are settings that we did. And it came through our rule, which comes through this star. It matches against star. Everything matches star. And that's the weakest rule, by the way. So if we can overwrite star very easily because that's very low in specificity. Remember, the more specific a rule is to a particular element, that will overwrite any other style settings from less specific rules or less specific selectors. So then we look here, look at this body element here. Do you see that? These are the weaker. This is star. That's the weakest. When I'm looking at that star right there, this thing, I cannot open this thing up. Wonder how I get this open. Anyway, this tiny little view here. Maybe that's better. Not really. What the heck? Can't bring that down. There we go. So then more specific than that matching star is, oh, look at this, is this one, because this one appeared first, right? Let's see how that looks. This one appeared first. I don't know why it's listed second like this. Green and dashed. This is green and solid. So it turns out to be solid. So the one on the top is the one that's dominant here. Because the border style is solid. It's not green, see? So that's because I put this rule is listed first, and then I list this one after that. And if we made this dotted, say, it's going to come through as dotted. I don't know if you can see it, but that is dotted. Maybe I should make it dashed. And I make this solid here. So you won't be solid anymore because this assignment here, this rule is being overridden in the very next line. So the order matters, you know, how things appear. There's the dashed. And I think you can adjust the dash as well. And now look at the body element. So look, if you look here, this star is matching against the body element. We're getting a dashed border style. It's green and 1 pixel. And then here's another assignment. See, now if we take that out, like maybe we don't even want this in there. Just take it out. See, we got to reload. Let's get rid of that, so we don't even have to look at it now. See, and now it doesn't show up. It was completely overridden anyway. And then we have this body selector. So that's matching against our body element, which I have highlighted here. So it's showing in here what that element is. You can see the border in there. And the border, the margin is 8 pixels. See that brown? See that brown around there? That's the 8 pixel margin. So let's get rid of that. And usually see something like this. So it'll be body, and you know, we can do margin left. Watch this. Margin left 0. You don't need to, if you put a 0 in there, you don't need the units, by the way, because it's 0 pixels is the same as 0 inches or 0, you know, whatever units. A 0 is the same. You know, you don't need units when you use a 0. But we'll put pixels in there just to be, I don't know, rigid about it. So I'm getting rid of this left border here. See that border right there? That brown border on the edge there is what's colored brown by the browser. I can reload this. There, I got rid of the left border. See that? And the margin. Well, it's a margin. It's not a border. It's a margin. Sorry. So we're going to get rid of the whole thing. You know, margin left, and then margin right, and margin top, and margin bottom. Make the margin top 100. And make the margin bottom 0, and the margin right, we'll make that 50. Let's see how to make that look. So there it is. This margin top is 100, margin right is 50. Now, there's an abbreviated form of this, and you just do it like this. You do margin, colon, and then it'll be, I think it starts in the left. Maybe it starts in the top. I can't remember. Let's check it out. 100 pixels, and then you go to the top is 100, and then the right is 50, and then the bottom is 0, and the left is 0. It's either that or you start with the left. I can't remember now. And I'm going to get rid of these. This is an abbreviation for that. Yep, there it is. I got it right. So the first, in this abbreviated form, this is the top, this is the right margin, this is the bottom margin, this is the left margin. So you can abbreviate that. Instead of 4 separate, rules, you can have just one rule. If you want all the margins to be the same, so you want everything to be 100 pixels, then just put in 1 in there. Now everything is 100. The margin's 100 around the body. And if you do it like this, maybe do 150. That means the top and the bottom become 100, and the left and the right become 50, I believe. I never use this. There to see the top and the bottom are 100, and the left and the right are 50. So that's how the CSS machinery interprets 2 values listed here. And if you had 1 value, then it's the same all the way around. And I'm just going to zero it out here. There we go. We zeroed that out. And let's see, this is the canvas. Notice the canvas, there's no padding in the body here. And I wonder if I put body padding in. Let's do, if I do padding 50 pixels, what's going to happen here? And there's the padding. So the padding of the body element was apparently was 0 by default. Now, different browser, that's the browser's default, by the way. So maybe we don't want to rely on that, and we'll just to make sure, we'll set padding to 0 on the body element, just in case we can get to a browser that has a different default for the body element. Also, this, I think this, yeah, I can say anything about that. So let's keep going here. There's the compass. And let's suppose we want to do some animation. Let's just see the basic animation here. So we're going to move this. What we need to do, watch this, I'll show you a simple animation. There's a set timeout function. And we can execute this function here. After 3 seconds, 300 milliseconds. set timeout takes two arguments. It takes a callback function and it takes a number of milliseconds to wait before it calls the callback function. Let's see that work. We'll do an alert here. Just going to say hi like that. So once after we're going to call set timeout, we're going to wait 300 milliseconds, 3,000 milliseconds. Milli means 1,000. 3,000 milliseconds means 3 seconds. We're going to wait 3 seconds, and then the system will call this function. We'll see an alert message saying hi. Let's see if that works. Doesn't seem to work. No, that's because there's an argument. Oh, there's an error. 26. Something with 26 here. Let's see, that finishes this. Set timeout. Oh, we didn't, there should be a parenthesis there, sorry. 1, 1,000, 2, 1,000, 3, 1,000. There it is. So you're going to do this simple animation. What we do is, you know, when our 3-second wait happens, right? We're going to take we'll take these two lines right here. Watch this. And we're going to change the fill style to blue. And we're going to fill the same rectangle. All right. Let's watch that work. 1, 1,000, 2, 1,000, 3, 1,000. So see, the animation has to do with waiting some time. Here we're waiting 3 seconds, and then we write to the canvas. Well, maybe we wanted to write a little bit to the right. So this is the X position. Let's change that to 15. No, let's change it to 20, 25. Say. Okay. So we're going to shift that. We're going to shift that square to the right a little bit. 1, 1,000, 2, 1,000, 3, 1,000. There it is. Oh, but see, now we're moving it. We're changing the color and we're moving it too. And maybe we didn't want that little edge in there. Maybe we want to completely, you know, replace with the other one. Actually, I'm going to make this. I'm going to bring this down to 2 seconds. I'm just going to go down to the right and down, so moving that direction. But see, what we could do is we could clear first. We could set the fill style to say white, and then do a fill rect. We're going to get the whole thing. So we're going to get the canvas width and height. So it's canvas dot width, canvas dot height. We want to set we're going to cover the whole thing. So we set the fill style to white. That's the color it's going to draw with. Then we say make a rectangle that covers the whole canvas. And then set the fill style to blue, and then draw this rectangle at this coordinate here. So just take a look at that. 1 second, 2 seconds. There it is. And then you could do something like, all kinds of things you can do now, right? So you could do it like, we can have the x coordinate start at 0, and we can let the y coordinate start at 0, and say set interval. Right? I think they call it set interval. So that means every 2 seconds, this function is going to run. let's just, I don't usually use the set interval, but it's not that useful actually. I'm just showing you the cheap way to do it here. And then this, when we fill the rect, we're gonna put it at XY. See, put it at XY. And then after we do that, we're gonna change X and Y. We're gonna let X equal X equal X plus say 15. And then the Y equals Y plus 10. That'll be every 1 second. So we're keeping track of where we're going to draw this thing. And maybe we'll start blue up here. In fact, we don't even need this here. Just take this out. There it goes. So it goes forever. And if you say, well, it's going a little slow, let's speed it up by 10. And it's still kind of jaggedy there, right? It's gonna let's make it a little faster. Every 50 milliseconds. Let's see how well that works. It's still not very smooth, right? Look at that. It's a little jaggedy. 17 milliseconds. That's 60 frames per second. Okay, that's like a video game. That's kind of a standard video game. It looks it's quite a bit smoother there, isn't it? And this setting the interval, that's one way to do it, because this thing is still going, right? It's X and Y are hitting in the billions right now. So that's at some point we'll have some kind of overflow. It's in an infinite loop right now. We can't see it anymore. Now this is not the preferred way of doing this, because the granularity of this timer is not very good. So there's another, when you're getting down to these frame rates, 60 frames per second or so, then you want to use a different approach for the simulation loop. And you do it, and I'll show you how to do that. There's a function, but let me do it a little differently. Let's do it like this. Let's create a draw function here. Here's a draw function, and when we draw, it's it looks like this. Oh, let's call it update. We'll call it update. Nah, draw is better. Draw is better. And let's take all of these. So here's our variables X and Y. These are not global because we have them in this function, right, that we call immediately right here, this anonymous function, right? So X and Y are locally scoped to this anonymous function. And then we have the draw method, which operates on this X and Y, and uses X and Y here to fill a rectangle. And this fill style, we keep setting it over. Oh, here is white, right? So we clear here. And now the set interval would look like we want to call the draw function every 17 milliseconds. So it's a little easier to look at that set interval now. So we want to run the draw function every 17 milliseconds. And basically get the same result. Okay, that's one way to do it. And now I will show you the preferred way to do it. Instead of calling it this way, we have this, was it set animation frame? Is it set animation frame? Anyone remember the name of that thing? Animation frame. Is it set? Oh, request, that's the thing. Request animation frame. So it's request animation frame, and we're going to pass in our draw function. We're saying that when the browser we do this request animation frame draw, we're telling the browser, hey, just before you draw your viewport. See this here, this line right there, down in here. This is a viewport in there. The browser's going to draw its viewport, everything that's inside here. Like see how I underline and I hover away and there's no underline. See that? It's probably running around 60 times a second, right? And so that's an animation. These are animations in the user interface. This is it. It's running around 60 times a second, and it has to draw things. When I hover there to say, oh, we got to draw that with an underline, and I hover away and say, oh, now we got to draw it without an underline. So, it's clearing the whole screen and redrawing everything. I'm pretty sure it clears the whole screen and redraws everything. Everything is getting redrawn. Look at all of this stuff is getting redrawn every 60 seconds. I mean. See, there's a lot of speed in there when you're doing it with graphics. But you don't see it. It's all an illusion. Everything looks slow, right? But things are getting redrawn. So you're saying, hey, browser, before you redraw your viewport, call my draw routine. Call this function. And this function will, operate on the canvas. And then once we draw on our canvas, and we return from this request animation frame, when we call this, it ends up calling our draw method. And then after we return from this, at some point, the system will, the browser is going to clear its business. And then when it wants us to, our draw method to run, then it calls it. All right, so let's see. Now for the loop to work, see this is a one-time shot. It's only going to call it once. You'll see this. It won't be animated. I'll just call it once. Because when you call a request animation frame and you pass in draw, you're saying, call draw on the next frame. That's it. And then forget about me. So it's only going to call me once. So we got to put it inside the inside the draw function itself. After we do our drawing operation, we're going to say, well, we want to be called again in the next frame. So we have to register ourselves. The function has to register itself to run again in the next frame. Now we'll get the animation. There it is. All right. Now, how do you do this? Let's create a frames per second counter. Let's see how many frames per second we've got. We're rendering at. And this request animation frame this is it. This is the callback function. Look at this. Window request animation frame. So that's, remember, Windows is a global object. So it just means it's in the global namespace. And this is the syntax. Window dot, now this is optional. I didn't include it in there because it's global. And then you have the callback. You have to pass the callback in. And here it describes the callback. And it says the callback function is passed one single argument, a DOM high-res timestamp, similar to the one returned by performance now. So this thing here, the type is a double. It's used to store a time value, so it's a double. The units are milliseconds, and they should be accurate to 5 microseconds. That's a lot of accuracy. So this draw function can actually take, a time value. So I'm going to put it in as, well, not t. I'm going to put it in as millis. That's how I do it, just to remind myself. Those are milliseconds. And I don't like to work in milliseconds, so let's set t to millis divided by 1,000. Make sure that's floating point. Put a period in there. And although I'm not sure you need that in JavaScript, actually. Do you need that in JavaScript? If I did 20 divided by 7, I get a fraction, right? I don't get a whole number. Okay, so that's different than other languages. Probably don't need that in there. Okay. So we have this time, and now we want to make this rate dependent on the time. So it's 15 pixels per second. So we just multiply by the number of seconds that have elapsed. So it should be something like this dt here. So we want to multiply it by the elapse. Remember, this code runs every frame. So we want to move things based on the amount moved depends on the amount of time that have elapsed since the last frame. So to get that time, we have to keep track of, the current time. And what was this? They said something about you can get this from performance now. It returns, I never used this before. I just noticed it in the documentation. So this is a way to get the current time. Look, for security reasons, they can't have a high performance timer. There's there's a Spectre attack that's enabled through a high performance timer. That's interesting. So the return value represents the time elapsed since the time origin. What the heck? That's interesting. Beginning of the current document's lifetime is calculated like this, so that's quite interesting. And so we set an initial value for t, or I could just set it to 0. Why not just set it to 0? Although it's better to use this because then you'll get the initial frame may be off. If you don't do this, this will be a little smoother. So when you get the new millis, right, then you have to calculate the you have to calculate the time, the current time, and then you compute the dt. That's the so this is the current time. So this would be, so dt would be the current time, which is millis divided by 1,000, and minus the old time, which is t. And then you update t to be millis divided by 1,000. Is there a better way to do that? Is that the better way to do that? Let me see. So the dt is convert to seconds, subtract the old time, update the old time, and now use the dt values here. And there we go. I think that's probably all right. Not working. So this is the x and the y, and this is the this should be times 1,000, or divided by 1,000. I think that was it. There we go. Now it's going slow. So it's so this rate here, it's 15 pixels per second. There we go. So now we're, we know the speed at which we're running at there. 35 pixels per second, 45 pixels per second. Let's see. One's a little faster. 45 pixels per second, 145, 100 pixels per second. Let's see. There we go. So we get the rate. So that's how you use different rates here. And let's see what else we want to do here. 440. All right. So now we're going to build this thing out. Let's get our FPS counter in there now. So the FPS counter, we have to render text. So the text will be something like, let's do this. We got it. There's something called a font. We need to set the font, which is say something like 24 points times Roman or something like that. How do you set the font? Let's see. JavaScript, context, canvas, font, set. All right, it looks like this. "30-pixel Arial" is an example. And then you have fill text. So it's going to be, CTX, the context, and then fill text is the function name. Then it was the text that you want to draw. So say hello, and the location, say 2020. So that should say hello. There it is. Okay. Got to come down a bit there. Make it a 50. And look, it kept the color. Did you notice that? It kept that blue color because we would have to change it. The fill style here. We'd have to give a fill style of that right? Fill style? Yeah. Now it's purple. So this is a context. So when you do draw operations, this is like a single variable fill style. So you have to set it before you run fill text or before you run fill rect, say, or some other fills. Anything that does drawing to the canvas is going to use the color set that fill style is set to in the context. So let's see now. Now we want to make this an FPS counter. So we've got another variable up here, and we'll let FPS equal say 0. And then we'll set it at 60. And here, the fill text, this will have to be, see, I think we can do just FPS like that. But if that gets rejected, we make it a string by using this concatenation operator with an empty string plus, and this is a double, so you're going to get a data type conversion to a string in order for that concatenation to occur. But the function it's expecting a string here. Well, if we pass in a double, is it going to handle it correctly? I don't know. I don't think so. Well, I did. So it converted it to a string for us. But if it was a problem, I would have done this. Make sure it got converted to string first. Maybe that'll fail with other browsers. I don't think so. Probably calls toString on this, something like that. All right. So maybe I'll put it in there just to be formal about it. So now we got to update this FPS counter. So that once we get these milliseconds here, right? This is the elapsed milliseconds. So that's the time it took since it drew the last frame to drawing the next frame. See, so we're going to average that into our FPS counter. So we're going to take 95%. So we're going to do a floating average. So FPS will be 95% of the current FPS value plus 5% of the new value, dt. Maybe 95 is not, maybe 99. Because remember, these frames can come flying at us, and we want to smooth out the FPS number because the system might get bogged down because it's overloaded. Maybe doing Windows update or something, and everything slows up. All the threads go put to sleep, and then the next frame takes 400 milliseconds. And so we don't want to bump to 400 and down to 0. We're going to get too much variation in the number. So we create what's called a moving average. This is a moving average. So on the FPS counter, we get a new value that represents a frame duration, dt, is the duration of the last frame, the current frame. Then we want to use 1% of that to merge with our current FPS amount. So let's see how that works. And you could start anywhere. You could start at 30, or you could start at 10. I'll start at 10, and it'll go up very quickly. Watch, see that? No, it's going down. What the heck? Something's not right. So the dt is in seconds, right? So dt is dt is is seconds per frame, right? Well, we want frames per second, so we need to turn that into division. There we go. That'll converge up to 60. Because the moving average is converging to, whatever the real average is. So it's edging up there, but it's going to be, it's hitting 60. Look at that. Maybe if I resize the window, there's a little glitch. Watch, maybe a little glitch happens. See that? Dropped a little bit for a second. See, look at it slowing up. See, look at it, 57. See that? Like moving around. So the frame rate is dropping on us there, but now it's coming back up again. But I'm gonna just start it at 60, so it converges faster. There we go. It's roughly 60. It looks like a hair below 60 on average right now. When I resize the window, the frame rate drops a little bit. But see, by using this approach in the animation, DT is real elapsed time. So we're basing the animation on the wall clock. The wall clock time. Not the number of times our draw code gets called over and over again. So we don't want to assume each time the draw call gets called, that we have the same amount of time as elapsed. So DT is a variable amount of time that gets elapsed between draw calls. And that's why we use that in these distance calculations, get a smooth animation that's connected to the wall clock. All right. I'll keep cranking here. Now, here's the problem at this point. We're learning about Canvas, and we say, oh, I see. I got an idea how to do animation, and you're just getting the rudiments here, right? And the problem at this point, because you're learning some very specific, a specific collection of tricks or techniques here, but how do you use this as a piece of a much larger system that implements something like a video game or an animation of some kind, or some kind of interactive user interface? So that now we have to figure out how to manage the complexity. How are we going to grow this code? How do we organize it so that the code can grow and that we can build out an application of some complexity? So that's where the hard part starts. That's where you've got to really spend a lot of time thinking on that. And I'm going to show you, we talked about prototypes, and I'll show you an approach that uses prototypes. All right, let's do that. So what we have is, we have two things here. We have a square going across the canvas, and we have this counter, frame counter. So we basically have two, you can think of those two game objects. So these are two game objects. And we're going to have additional game objects. We're going to do other things, like respond to mouse clicks and so on. So we have to think in terms of game objects, and what do game objects, they all need this draw method here, right? So to think of a game object, let's do it like this. Maybe we have think of it, say this text. Let's suppose we're going to want to show text on the screen. So maybe we have a function that's called text. We'll do it like this: function text. and the text will, set a fill style and right here, these three. So we want to draw some text, and what we want to do is we want to draw that text at position X and Y using this font and maybe this color. And then we would end up doing something like this. Well, maybe here. And then we're going to do constant we'll call it the hello text. And we'll put it at 20, 50. And, orange. And the font is, what font did I use? Here. Oops. So we create this text. This is like the game object, and so we're going to create this object. We'll call it I don't know, call it T for text, and so it'll be we call text, and sorry, it's going to be, we're going to create a new object, and it'll have a field, the text field. So we're just going to get it from the arguments. We're going to save our arguments as member variables. And let's see, same with color. And then we have t.font. So we created this object here. Now we're attaching these arguments. We could do it a little differently. How about we do it like this? And we could put the text, in here. And then I have a comma here, and then X. And here's the other way to do it. And so there's lots of ways of doing the same thing. No comma there, it's because it's at the end. So I could take this out. So we create this text object like this, just to make it a little easier to look at. Let's line things up. So these are attributes coming in. And we're just saving them as as member attributes. So this object we're creating this is called a factory function. Okay, so we're going to create a text. We're going to create an object here. We're calling it T internally here, and then what we need to do is define a draw method. And the draw method takes milliseconds. So when its draw method is called, there's a context object, which is defined here. And we set the fill style to the the object's color. So this dot color, and the font is the same thing, but this dot font, this dot font, and then we have the fill text is we're going to render this dot text and at position this dot x and this dot y. So there's the draw code. And that's what we got. That's good enough. So this is a hello text here. Pass that in. And of course we don't need this X and Y. We're going to get rid of that. This T we're going to keep in there. This FPS we'll keep that in there. Well, we don't need it right now. So I'm going to, just to prove that to you, I'm going to take that out. Let's take that out for now. And then, so this is the DT calculation. That can be const, by the way, because once we set it here, we don't change it. And then this T is this one up here. We have to use let there because look, we reassign T here. And here's another chunk of code that we're going to use to show our architecture with. We're going to keep it out for now. We're just going to render. We're just going to render the that one hello text here. So this object here. Once we calculate this DT, and update our our running record of the time, then we can call the draw method of hello text. And there's the hello text right there. Oh, this says millis here. Well, we're not going to pass millis. We're going to pass in seconds. All right, because we can ignore it here because we're just rendering text, so we're not doing anything here. And this T, this T looks like time. So I'm going to replace it with an O. It's an object. So we create the object O. And, oh, look at that. See, a refactor and I see mistakes. I'm going to return the O. So this is, we could call it create text. Would that be easier to understand? How do you call it create text? And then this is the new text object that we create. Now here we return it. All right. Maybe that's not clear. So we define the create text in here. Then we create an instance. We call create text. Call create text here. And then we have to make sure that we call it in the game loop here, the draw method. Remember, this is the draw method, the main draw method. It gets millis. We convert it to seconds. And then we could pass, we're going to pass seconds. We're just going to work with seconds. It's inconvenient to work in milliseconds. So whenever you get the policy that I follow is whenever you get a millisecond value, just convert to seconds. And then you don't have to think about time units anymore. So let's see if that should just render a hello. There it is. Now, now that we have this generic sort of method of creating text, then we can do things like this. We create a by text now. here's a by text, and bye-bye. There we go. And then the x value, say, we'll put it at 200. The y value, we'll put it at 150. We'll put it in pink, and we'll make it 20 pixels. Sorry, not pixels, it should be points, right? 20 pixels. Is that, yeah, they use pixels here, don't they? So now we got this by text to manage, so we got to call its draw method as well. And now we have two game objects. There it is. Now we can see. Now we do this in general. Now maybe we got another function here. It's call it create rectangle. So, getting a little late. I forgot what I was doing. So we could have maybe create a box. Right? And this, it has an X and Y location. It has a color. Maybe it has a width and a height. So we create a new this is a width, the height. We'll save those as member variables. Save the color. We don't have a font. Got to get rid of that comma right there. There we do. We create an object, and then we append a draw function here. There's a weakness to this design, which I can talk about in a moment. So we got the fill style, this is our color, and we don't have a font. And then we're going to grab this commented out code here. And we set the, we got that done already. Oh, this code here. This this sets everything to white. So this doesn't belong in here. This needs to be done before we do any drawing. So right before we draw here with our game objects, we need to clear the screen. So this is clear the viewport. And then we draw the game objects. This is the compute compute the elapsed time. DT, so delta time, DT. And then we draw the game objects. And then we, of course, we schedule, schedule for draw function to run in next, what do they call it, a refresh or something like that? In next browser refresh. Whatever you want to call it. Yeah, I don't like any of those, so I'm just going to leave it out. All right. So let's see, now what we're going to do is, what was I working on? Oh, the rectangle, the box. So we want to do something like this. You know, we're gonna have our, we'll call it the blue box, and this is create box. So you have different kinds of game objects. You know, you can have an enemy. It creates enemy spaceship. You know, whatever it is, you create these things, and then you have to make sure that their draw methods are called. So here's the box. Let's put it in 100, say 250, and make the box blue. We call it blue, and we don't need this. We have to have width and height, right? So width is say 40, and the height is 60. Let's do it like that. So we call create box, and we called it the blue box, and then we gotta, basically have to, put it in here. The blue box has a draw method, so we're gonna call the draw method of all these game objects. So we got this blue box here. Let's finish that blue box. Create box, and let's see. So the draw method here, we set the fill style. We don't have fill text, and that goes out. So we have to call fill rect. This is x, y, and the width and the height. But see, when the draw method is called, it's called against this object, right? And so when we refer to x, y, w, and h, we need to use this to tell the system that these are member attributes of the object that the draw method is being called against, which is that box, right? And let me just check up here real quick. Yeah, I did it like that here too. See, this dot x, this dot y. So let's see here. We got it. There. It's kind of low. There it is. I'm going to bring it up a little bit. We got to bring it up. Where did we create that thing? Here. We gave it a y value of 250. Let's make it 120. There it is. Now, if we want the box to be moving, then we're running out of time. This is, as you can tell, this is fun, right? Can you imagine sitting down in the morning with a couple pots of coffee or something, and no one's in the house but yourself, and 12 hours later you're still hammering out code? It really gets to that level. I mean, maybe not 12 hours, but 8 hours for sure. Well, I could just sit at home and just happily code for 8 hours straight. You just get into it. Anyway, that's enough, and we'll see some of you in the lab.